Welcome back, everyone. I hope you are doing well. Uh, Today's lecture will be on the design of sewers. I have given you some or how to design the water distribution networks. We took one of the methods, which is equivalent pipe method, and there is another three methods. And because it's a huge material, so maybe later we will come back to the water distribution network. But there will be mainly there will be four methods for the design of water distribution networks. One of them is the pipe network analysis, the pipe equivalent pipe method. The other one is the section method. The third one is we have section method, and there will be Hardy-Cross method. Uh, maybe this is maybe. If we have time, we will come back to the other three methods. In this chapter 6, now we have done with the water distribution network. There is another thing because our course is about water supply and sewerage. So today will be on sewerage and the main component and the sewerage, and the term sewerage, by the way, it will include the collection of the sewage, the term sewage. And the sewerage, it means the whole pipes, which is called in the sewers, by sewers. We have sewers, we have manholes, we have pipelines, we have high lift stations and other things. These are called sewerage. So the term sewerage is related to whole work about the sewer, the collection and the disposal and the convey of the sewage that we have. Now, in general, we have the wastewater, which is usually called sewage. Wastewater, by the way, the municipal wastewater is a general term. The sewage is the specific term. So sewage is the wastewater that the municipal wastewater. Municipal, it means that the household sewage is called sewage, while the wastewater is will be the municipal and the industrial maybe. The industrial also maybe the commercial areas, which maybe the site, maybe the stormwater, all of these all together is called wastewater. So the wastewater is coming from, it's a general term. And it will be referred to the whole activities, while the sewage will be just specific case from the wastewater, which is related to the municipal or the household sewage. And now, how do we collect the sewage? We know that the collection of the sewage or the wastewater will be, by the way, when I say the wastewater means this is will be related all to the factories for the industries, for the all commercial areas. Besides of that, the municipals. So the collection, it means that how to collect what we have from the household. We will dispose the waste to the sewers. That's called the sewers, and we have pumpings. We are in Slimani, we are not using the pumpings because we are taking into there is an interest from the topographic way of this city that we have a slope city area, and that's why the flow will be all by gravity. But in the flat area like Baghdad, like Erbil, and the most land are flat area, and these areas you cannot go with the gravity because the sewage should go with the gravity, but when we have a sloped, we have non-sloped area, the flat area, so you will reach a point and you have to excavate a very deep holes to just put the sewer, which is very impossible. So what we have then, we will put a manhole which is called a drop manhole, and then this drop manhole just to go, it means that, let me say, if was the land, we have a manhole here, This is called manhole. And there will be a pipe to just convey wastewater. There is another manhole here. There is another manhole here, and there is another manhole. So you can see the slope of the manholes, it should be enough just to let the flow will be within gravity or gravity flow. Okay. Now, if the flat area or the area was flat, you will reach a point that is this is called excavation. The excavation of the land will be very high. It means you will reach 7 to 10 meters, and after that it will be impossible to excavate a trench and then drop a manhole, and then will be we cannot, it's not called a collection, and it will be you have to find another solution. So what should we do in the flat area? This is what we have in the flat area. In the sloped area like this, what we have in Slemania, we have the first manhole here. Usually the first manhole depth will be from 1.5 to 2 meters depth. But the other, this will be control. This is the control or the starting. We can control the starting manhole, but the others cannot be controlled by us. It will be controlled by the slope of this line. The slope of this line is usually we have a minimum slope. Minimum slope, it should be a slope that will this slope of the line should be enough to just let the flow of the sewage should be go by gravity and not be accumulated here. Now in Slemani we have this case. The case is that already the ground level is sloped. So when we have a pipe, and mostly the pipe slope will go with the slope of the ground, then even you have, for example, how many we can put the manholes. This is manhole number 1, manhole number 2, and manhole number 3. Maybe 10 manholes. You can the depth of the excavation will still within the range, within the acceptable range. That means you don't need to just lift the sewage. While when we have a flat area like here, you will reach a distance. So what should we do? We will use a manhole, which is here's the manhole. We will use a manhole. It's called will be another manhole beside this one. So we will put a pump here, and this pump is just to lift the waste to the other manhole, and this other manhole is depth will be just look like what we have. The other manhole will have a small excavation. So what will we do? We have, this is called lift station or drop manhole. So this will be submersible pumps. Submersible pumps, it will be, we have a sensor for this one. It will tell you, the sensor will act, will start will start the pump to be on when it has a certain level. There is a floatable switch. So when we have a floatable switch here, it will let the pump act and empty the waste that will be collected here to this manhole. And then there will be another manhole, and the flow will be also by gravity, and so on. So you can see we have 2 manholes. This is called drop manhole, and so on. This will be within the specific flat area. Now we have, this is called manholes. This is the one. We have the sewers and pumping and raising pipes. This is what we have for the collection. So the collection just for, yeah.
For the case of the flat area, the
Yes,
pump that we are using in the lifting stage,
yes.
is the drainage will be moved above the ground level to the another manhole, or it would be just
Uh, now
underground?
let me make it more clear. Um, where is it? Look at this one. Usually, look at this one. This flow. This is the pipe. In the sewers, this is called sewers. In the sewers, we don't have fully flow pipes. We have partial. This is called partial flow. Okay. So usually you have to leave a space, a volume. Why we need this one? Because there will be an aerobic reaction. There will be H2S. There will be methane gas, and there will be CO2. So these are the gases. So we need not, we have to let these to skip the gases. Otherwise, we will have a collapse. Now, your question, why we need, how this pumps will work. Let me say this is usually the manholes will be look like this. There will be this is a cast iron cover, okay, and there will be will be a concrete sewer, and usually the distance will be about 2 meters, 2 meters or 2.5. Now, these manholes, we have in the bottom of this manholes a shape like this. Now, the pipe, this is the incoming pipe. Got this one? This is the Q, income in the flow from the other manholes, the upstream manholes. There will be the collection, the wastewater will come here, and it will be collected in this way. And there will be another sewer just after this, but it a little bit higher than this, a little bit. Okay, now you can see there will be another manhole. What we have here in the next one, there will be, this is the natural ground level. If you have a flat, it will be like this. So what will be here, the difficulties that we have facing here, is that we need to have a more deeper sewer, a more deeper manhole. Okay, so we need to have a more deeper manhole. Now, about if I reach about, let me say, 7 or 8 meters depth, so it will be impossible to again, or it will be very costly to have an 8 or 9 manholes depth. So what we will do, we will uh, uh, put or use a pump here. Um, we will use a pump in this manholes, and this pump will be here. This pump will be, this is called a pump, and just look like what we have here. This is the inlet, and there will be a pump here, and there will be an outlet. This is the pumps this way. This is called sewage pump. This sewage pump can lift the organic materials, and besides of that, it has an possibilities to have at least the gravels and gravel and the stones of 2 to even 5 centimeters diameter. So you can imagine this waste can be collected here, and it will be dropped. Where to drop? It will be dropped here. We have besides of this manhole, and you don't need, or we will just put it in this way, but it's not deep. We just put this manhole beside this the other manhole, and it will work. This manhole, this pumps will work when we have a float double switch or on and off. So when the level of the waste in this last manhole will reach a certain level, the switch will turn this pumps on, and it will just work until the load in this manholes becomes like here. Then it will stop. So on, off. So was the pump's duty? It was just to empty this amount to this manhole. And what's the situation in the next besides the manhole? It will work again like what we have here by gravity again, and until we get another manhole with the same depth, and there will be another pumps and so on. These pumps should have auto on. It's not auto on, it's floatable switch pump, but the pump electricity will come down with this manhole. It will be hanged. Then will be a electricity cable inside this used, and it's a specific pump for only just 15 station. Is it clear now?
Thank you very much.
And by the way, the problem of don't having electricity in such kind of area, it will directly affect on the collection and the dropping down, disposing the waste in the manholes. That's what we have. Just a minute, please. Can you hear me?
Yes, sir.
Okay, so we say that we have a problem with the flat area, and this will be the cases. Now, the main difference between what we have in the sewer design and the water distribution design is that we have a non-fully flow, we have a partial flow. This is one. Another thing that we are in the sewer design, we are the first manhole we will start. Let me just give you a short how to start designing a manhole. Let me say if you have an area like this, as was a city. For example, this is a house, and this is another house or a block, and this is maybe a master plan of this area, and we have like this. So if you are, as an engineer, you are responsible for designing the sewers of this area, what we should do, first of all, you have to look after the slope of this area. I mean by the slope, I mean I want you to take these points. These are points that have been surveyed, surveyed by the engineer. So they will give you the ground level of these points. So within the ground level, you know that there is a points, for example, I have 915, 948, 947, 946. So what these numbers are telling you, 949, 952, 953, 954, 955, 949, 948, and 949. 49 again. So what these numbers are telling you the topographic of this way. So you have to, this is first of all. So what should we do? Firstly, you have to start putting the manholes in each interconnection points, in each corners. So for example, here we should put the manholes. Okay, now we have these manholes. So how many manholes that we have in this one? You have to number the manholes. So manhole numbers. Now look at the highest level. The highest level is 953, 955. So maybe this is the highest one. You will say this is manhole number 1. Now after that, you have to look after the direction of the flow, of the sewage flow. So we will start, we should take the benefit of having the stop of the area. This will let the cost decrease by 50% for you and for the owner of this project. So we will start with 955 and then, so this is sewer number 1. 954, 953, there will be another sewer here. Can be sewer number 2 and sewer number 3, and there will be another manhole here. Now look at, there will be here. So the direction of flow is here, 1, 2, 3, 4. Okay. Now 952 and 954, which one is will be more suitable? You are, as an engineer, you can forward the sewage, the collected sewage from this region to this area, and from this region, from this pipe to this one, and there will be another one. Now there will be like this, there will be like this, and there will be like this, and there will be 949, and we have 946. So it will be better to serve this area by this way. Got this one? And we have an area here, it's missing, so you should put another manhole here, and you have to look at this one. Now the flow will be here, and we have to follow the direction of the flow. And yeah, so this is called the layout or the sewer collection system. Now, as an engineer, what should we do? We should, and this is for your project also, you have to find the, first of all, you have to find the manhole number 1 levels, means levels. You have to say, where will be, this is the typical manhole. We have a typical manhole. The typical manhole we should use this way. In the typical manhole, we have, it is called top surface or top surface level, and this is bottom surface level. So we have to have for each manholes the level here, how much it will be the level at the excavation, because we have to tell those people here, please excavate for me about for example 5 meters. So the depth of the excavation will be based on the cover level and the bottom. This is one, and the dimensions are standard, but we have the in and out. For example, in, I means the level of the pipe in and the level of the pipe out, Q out. So what will be here, this is called invert level, and this is invert level. So invert level of the pipe, the sewer that's in. Invert level of the sewer that out of this manhole. And we have as a standard, we have 10 centimeters. We need to have, this is a dead, let me say, a dead volume, because we want this sewer, if it has some, let me say, solid materials, high materials, or the materials that they are stones and something like that. We want these materials to stay here, not to escape to the next sewer. So that's why we will leave or a space from the in and the out. The out should be at least higher than the in by 10 centimeters to just let the flow slow down, and to settle down the all huge materials or high materials in diameter to stay in this manholes. And then this manholes cover can be used. For example, we need to clean these kinds of manholes every 3 months to 6 months and get out all of the collected or solid materials in these manholes and keep the sewers clean. And there will be a ladder to just help the people to come down and clean these kind of manholes. Now we have, as an engineer, we have to know these levels, this levels, and this level, and the diameters of the in and out. So sometimes this is called one key. If this was the manhole, this is the top view. So we have in, we have out. So we have one in, one out. Means we have one sewer that will enter this manhole, and we have one out, one sewer will leave this out. Sometimes there will be a sewers like this, in, out. So we have 2 in and 1 out, which is here like this. This is a manhole, 1 in, 2 in, 3 out. Sometimes there will be like this, in, out. There will be in, out. And the worst condition is to have 3 in and 1 out, okay? And the last manhole is called fall, or drop manhole, or falling point, like what we have in the Qiliasan streams. The last point, or the fall down, and the drop manhole, or the point that we have to the last destination of this collected sewage. This is the layout, and when you are submitting a design of the sewer, you have to mention what are the manhole number, what are the diameters. As an engineering, usually we have to build profiles. It's called profile. Profiles used for, as an engineer, to do that. In the profiles, there will be like this. This is all, and that's what I need from you to do it in the project. Will be the distance, or let me say station, 0 plus 0, 0, and 0 plus 100, 10, 0 plus 0 plus 20, means 0 plus 30, 0 plus 40, and so on. What that means you have also within the layout, this is 0, 0 plus 10, this is 0 plus 20, this is 0 plus 30, and so we have in 0 plus 30, it means 0 station, 30 meters. We have another manhole, so we have to mention that one in the profile. I will say there is a manhole number 2. There will be a manhole number 1. Okay, and you have to mention the ground level and manhole cover surface level, bottom surface level, and here's the same. So you have to mention 3 numbers and you have to put it in a level that is mentioned. Now this maybe we have the ground level, you have to mention this one and the cover, and there will be a bottom surface level. Here's bottom and there will be a bottom. So this is will be manhole number 1, manhole number 2, and here's you have to say the sewer. Sewer, you have to mention the diameter, and you have to draw this one. Usually the engineering values on the people working in the site, they need this profile. They are working in this profile. And usually for each profile, it's advised, or my advice to you is not to include more than 5 manholes in one chart, because the one chart will become like this, 2 A4s. When it will be more than 2 A4, it will be make difficult to read the data and it will confusing. So I will, my suggestion for you when you are going to design this kind of manholes, not to include more than 3 to 4 manholes in one profile. It's called profile 1, and you have to number the profile and the distance, station 0 to 030. And this way you have to complete for each, and usually there will be, this is will be 1, 2, 3, 4. This is will be profile 1, this is will be profile 2, and there will be another profile 3 and profile 4, and that's it. The project will be done. This is as an engineering and as a drawings. Now the main points is to, the surveyman will give you the ground level elevation. The left is, it belongs to you. You have to give all those numbers, all the diameters, all the lengths, based on what we will take it in this lecture. Do you have any question regarding these steps till now?
Doctor, the only purpose of having a manhole is to collect the solid materials?
Yeah, not the sewage. We have to collect the sewage from the households, and in each corner you have to have a man, and for inspections also. Usually we have, there are many conditions that we have to use the manholes in it. Manholes will be used at each change in direction. I mean by the direction of flow, sewage flow. When we have in this way, you can see in this layout, the direction of flow will be from here and there will be here. So you need to have a manhole. This is one. This is must. And also, when we have a high, sometimes when we have, let me say, there was not any change in the direction, but the distance was more than 150. So from manhole, you want to have another manhole at least. Maximum distance to have a manhole, it should be from 0 to 100. So every 0 till 100, you should have at least one manhole. For example, if I have 150, so you have to have a manhole in the beginning, a manhole in the end, and a manhole in the middle. This way, the distance between the manholes should be kept less than 100. So the distance, the net distance between manholes should be less than 100 meters. This is must. If there wasn't any change in direction. 3, it's used for inspection. For inspection, it means and maintenance. And whenever we have any clogging and what we have to do, how to clean the sewers, you have to have start. For example, if you want to clean this sewer, what should we do? We will use this manhole and this manhole for cleaning. How to do that? You have a specific techniques to clean the manhole. So manholes are very important to have it. And there's other 5 to, I think, 4 to 5 3 points that will help us to use the manholes. So yeah, also sometimes it will let the velocity to control the velocity of the sewage. And also for number 4, we have for gas escape. So the gas that is escaped, when we say that we have a manhole here, and the slope in this way, so the gas, the collected gas, and as I say that the sewer should not be fully flow, because the gas will come back and in the beginning, in the starting manhole, so you have to put a ventilation stack here and not to, otherwise it will come back to the houses. Okay, is it clear now?
Yes, thank you very much.
Okay. So as we said, we have, this is the systems. We have for the sewage, we have domestic. This is what we call it at the sewage household. And there will be industrial and rainfall and infiltration. What is the industrial? You know that we have industries and the waste will be. Unfortunately, we have for Slemania, we have a system called combined system. Combined system, it means that everything will be thrown to the sewer. If you have an industrial waste, if you have a household waste, if you have any, even the rainfall waste, the rainfall, the stormwater, all of them are using one sewer pipe. That's called combined system. Infiltration, while we have, for example, in those areas that the water table is very high, when we have a water table like this, these sewers, for example, if I have concrete, so if this concrete sewer is laid in a soil which is water table is higher than the sewer, so what will be there will be a kind of inflow. The water will infiltrate the body of this sewer itself. So it will add another additional load to the sewer pipe, besides of the one that is used for the convey the sewage. So infiltration is the inflow of the water table height. That will be if we have a water table, high water table like what we have in Baghdad or the southern area. The water table is about 1 meter to 2 meters. So excavating for 2 to 3 meters for the pipes, and you are using a concrete pipe or clay pipe, then it will help, or the water will be infiltrated through these pipes to inside the sewer itself. So it will be used for that. 99.9, which is not the elections results, by the way, this is the percentage of the water that will be included in the wastewater. And only 0.1% will be the solid materials of the constituents. We have 2 types of the systems, combined and separate. What is that one? Combined, it means the storm flow plus municipal sewage waste. So the household, let me say, household sewage plus the stormwater, if they are collected in one system served by one pipe, this is what we call it as a combined system. While we have separate, now for alluvial, it should be separate system. The separate system means that we have, for the flow of the storms, we should have a certain pipe. Means that if you have an area like this, an area like this, and an area like this, so when you are putting a manhole here, so for the storm, usually we are using the street gully, and there will be collection for the streets here, and it will be collection for the street here. So we have, this is called separate. This is, the houses should not connect their waste to these pipes. This is, will be illegal. Just we have to have the collection of the rainfall storms to these manholes. What they should do, the people, they should have another pipe, another storm sewer collection, which is called separate. So usually if you have a separate system, you have to have two pipes, one for the storm, one for the municipal. Means that you will double the design of the sewer. It looks like to be double of that we have in the combined sewer. So for the combined, the cost is will be half of what we have in the separate system. Is it clear right now?
Yes, sir. Thank you.
Okay. Now we have another method which is called radial system. The radial system, you have, this is contour line of the elevation. So what will have, well, what will appear to me that this point, this is like a hill. This is the highest level, and there will be a lowest level here. So what we have here, we have houses. The houses, they cannot drop their waste directly to the bottom. They have to collect it in a ringway, and then there will be another ringway, and there will be another ringway, and then we will have a pipe just for collecting this one, and there will be a pump station. There will be a pump station, and there will be a pump station and pump station. This is sometimes if we have the hill, and if I have like the area was look like this way, so what will be happen? The elevation of this one, this is the let me say it will be concave area. Um, these houses will be collected within a ring storm, and those are again those, so all of them will dispose their waste in the bottom, and then we can use a pump station here to lift to the other station. Horizontal system like this, what we have here, and this is the method that I told you, keep the with the elevation of the people, the elevation of the houses. Start from the highest to help taking benefit from the gravity. So the houses here are, their levels are higher than this one. So we have to go from the highest level, ground level, to the lowest ground level, and then collecting each of them within one main pipe or main sewer, and sending it to a pump station or a treatment plant, and also this one, another area. As I told you, we have the component of sewage, which is the sewer work. It will be sewer themselves. Laterals, the laterals are the connections between houses and the main sewer. And these laterals, usually we are advised by the municipals not to be more than 8 inch or 6 inch. That's too much. So 6 inch or 8 inch are the main two pipes, sewer pipes, that should we have from the connection between the houses and the sewer themselves. While for the starting, the laterals or the sewers they are start from the municipalities. They're asking us to start with 250. 250, it's about 25 inch. So this will be the start. There shouldn't be a sewer less than 25 inch, 250, 25 centimeters. This is must between from the government. Now after that, the laterals, here's the laterals. These are laterals. and there will be collection from the mains, and the mains are tunnels, trunks, and main trunk. The main trunk, it means the main station. We have manholes and inspection chambers. We have sewage, and we have raising force main and wastewater treatment. What we have for the water treatment plant, there will be a wastewater treatment plant just to treat that wastewater and treat what it can be treated, and dispose the legal waste. I mean by the legal, it means in terms of chemical tests, what can be drawn to the stream. And this is, we have a factor. There will be something called BOD test, biological oxygen demand, and total suspended solids. These are COD, carbonious oxygen demand. We have elements. Samples should be taken from the wastewater and should be tested for these materials. And then we have a legal. They shouldn't be more than 50 milligram per liter, and then it can be drawn. Otherwise, it should be treated. And here's the manholes, and as I told you, at each intersection we need to put a sewer manhole. We have a change of the sewer direction and diameter. By the way, if you have a sewer like this, for example, this was 8-inch, and there will be a sewer of, let me say, this was a 12-inch sewer, and there will be 8-inch. So how to connect between them? You have to construct a manhole here. So changing in the direction or diameter of the manhole on the source, you have to use a manhole for that. Or material, even the material. Sometimes this is concrete. This is HDPE, high density polyethylene. We have to use manually at in change of the materials. Okay, there will be a maximum distance. As I told you, the distance between the manhole should be kept less than 100 meters. And here's the typical connections of the source. As I told you, some of them in the past it was look like this. Nowadays we have a precast manholes. Precast, it means that it will be casted outside of the site, and it will be just put it excavated the site, and we will put it in this one, and just you have to connect for the source. This is the in, and this is the out. This is if we have just one in and one out. We want two in and one out. This is the in. This is, we have another in here, and there will be another out. So look at the direction. Sometimes we are using concrete in the bottom of this manholes to be look like this one, not for returning back or back flashing for the sewage to the previous manhole. This is, you have to be careful when you are the bottom of the manhole should be in a way you have to hatch this area, hatching this area in a way you have a slope like this, slope 1/3, and here's 1/3, and you have to keep a distance between 40 centimeters from the raising or the material that is the ladders and so on. Okay. I think I gave you a theory of this lecture. It will be too much if we go through the other materials. I will leave the second part, which is the calculations and how to find the diameters of the sewers and the distance and how to draw the profiles. So I will let that for tomorrow. I will send you a video or a tutorial of how the sewers and the sewer are working and what should we do as an engineer. And for tomorrow, I will give you the projects, and I want you to make 3 groups. So you have to group yourself to 3 groups. and I will assign for each of you a project, which is the same idea, but the area and location will be different for each of you. So you have to prepare for tomorrow the groups, and I will assign a Excel sheet for you, share with you the Excel sheet to nominate yourself for the groups. Okay. Do you have any question, or if it is it difficult to have to learn about sewers, or